Hi, and welcome at the PASC 2023 on stage. I'm here today with the Best Paper winner of the PASC conference, and Thorsten Kurth from Nvidia. And the paper who won the award is ForeCastNet, accelerating global high-resolution weather forecasting using adapted Fourier neural operators. So, Thorsten, first, congratulations, of course, for the award. Could you tell us what is this ForeCastNet about?
So ForeCastNet is a deep neural network which was developed for making short and medium-term weather forecasts. It was designed to basically match, or at least almost match, the skill of IFS, which is one of the best numerical weather prediction forecasting systems to date. So ForeCastNet can be integrated into the whole Earth 2 effort of Nvidia, and it's an integral part there that we want to accelerate weather prediction. Yeah. For not only for because currently the weather prediction is very expensive. You need to run it on big systems over a long time, and if you want to, for example, add changes to your model, or if you want to, let's say, predict different quantities, you have to add some domain knowledge, invest some. You need some domain experts who have domain knowledge to basically make the tweaks and improvements of the model to incorporate this information. So the ForeCastNet, which since it's purely data-driven, we hope that we can reach a broader audience, a broader base of people who try to do weather forecasting by, for example, making it possible to tweak the model itself, to incorporate new features.
So, do I understand correctly? Is this an independent tool that can be used, or is this a tool that needs to be integrated in the weather and climate codes, like, I don't know, ICON or other kinds of codes?
So no. So you need, of course, if you want to retrain it, you need the training data, and that can come from ICON, or it can be from the reanalysis data sets, for example, from ECMWF. So that you need if you want to train it. But once you have a trained model, you can also use the trained weights we are providing to make your own forecast. So you can just run it on certain weather
with your data
states, with the trained weights, directly producing the whole forecast on your own, on your desktop, basically.
What is your background, Thorsten? Is this climate? Are you a domain scientist?
No.
Are you a computer scientist? What is your background?
So my background is actually physics. So I did physics with focus on high energy physics. That was where my PhD is in. But I did a lot of high performance computing, large scale high performance computing in that, because I was working on lattice QCD, where you also have I think a session here about that. But then I switched to more on the computing side, HPC side, and now I'm working on all sorts of problems, and climate change and weather forecasting, and all these things which play together in the end are like grand scale, like big computing challenges of the future, and that is, I think, where we can make a big difference.
So then, a final question. How far or how close are we to start actually addressing the problem of climate change?
That's a
in
good
your
question.
opinion, huh?
That's a good question. So I think tools like ForeCastNet are a stepstone in that, but there's still a lot of. I think there's a little the whole problem is broader, right? So tools like ForeCastNet can help to get more of a, let's say, to raise awareness, also with policymakers in these kind of person who are actually in charge of changing things. Sure. And by getting the message out and making it more accessible to a broader number of people, I think it will definitely help in getting faster solutions. But on the scientific side, we are also very convinced that a lot of work needs to be done. So I will address some of these challenges in my keynote presentation.
Fantastic! This is actually a very good way of ending this chat.